Good morning, guys. Hopefully you've had a good weekend. I guess it was a long weekend for you guys because you had the Friday off. If you want to throw some green checks in, so you let me know you're with me and everything's working okay, and we'll get started. I see a good morning in chat, so I'm thinking things are good. Some green checks pouring in. Good. There's been a bit of a change of plans today. Unfortunately, Mrs. Ward is not feeling very well, so she's at home. And we're probably going to end up doing math for most of the morning. I know we did start a little bit late, so I'm thinking we'll probably do maybe like a lesson and then we'll take a bit of a break in the middle, maybe like 20-30 minutes, probably around 20. And then you'll have a little bit more stuff. And it kind of works out well where we're at in terms of this unit because there's kind of a bunch of ideas that are all kind of thrown together and give you some time to kind of digest it. You'll probably have a day later this week where you don't have math and you'll just have English instead. So it's kind of what's going to happen, likely. Looks like everybody's got some green checks in there, which is good. Everybody have a good weekend? Anyone do anything exciting? Go anywhere? I know you guys are all very busy. I had swimming lessons with my son yesterday. That was the highlight of my weekend. Anyone top that? A few people typing. If you would like me to go over anything from the learning guide, maybe let's just hold off on that for a second. I just wanted to mention a few things. We had some stuff from the lesson last day, and the way the course is kind of set up is different from the textbook and it's different from how I teach it. So it's all kind of like jumbled together. And I kind of went through some stuff last day, the exponent, rational exponent stuff that I probably should have held off on for a little bit. So what I'm going to do is I'm going to go through the next section, which is had a little bit of stuff that I introduced last day, and I'm just going to spend some more time on it. And then there's some additional questions that I'd like us to go through because this stuff gets really, not necessarily tricky, but it's just kind of a lot in one question. So just want to take a step back before we kind of go forward. And notice, Alex, you put some questions into chat there. That's good. Chloe made cookies. What type of cookies did you make, Chloe? Babysitting and some ballet. Well, it doesn't sound like a super exciting weekend, but I guess that's what it is. Sugar cookies, those are good. Did you decorate them with lots of icing and fun sprinkles and things? Those are my favorite type. My son likes to decorate the cookies that we make in our house. Yes, good. That's the best type of cookie. So I'm going to just take a quick look at the questions you guys put in here, and then I'm going to spend a little bit of time going over some of them. It's kind of weird how everything kind of gets mixed in together, and all the rules kind of show up in the questions, and the order I went through it last day wasn't the best, so it's a bit my fault. So I have a few questions for 3C and D, and then 6, 7A. So let's look at page 4 first, and let's have a look at what that was. Page 4, C and D. Okay. Three C and D of the learning guide. All right. So this is stuff that I probably haven't gone through yet, so we'll have a look at this. So the idea here is we are simplifying. So we're trying to get rid of any negative exponents first of all. This question isn't at that point yet. It's just all positive exponents. But we know when we divide with our exponents, we always subtract. So let's take a look at C here. The first thing I'm going to do is, I kind of mentioned this before, I kind of like just cross these numbers off and cancel them as we go. So I see that I have a common factor between my two coefficients out front here, I know 3 goes into 3 once, and I know 3 goes into 12 4 times. So I kind of cross them off the way I go. And then I see I have x's and y's and z's that I need to deal with as well. So you can do it this way, or you can do it, I'll do it twice again maybe. I see I have x to the 8 on the top, and then I have 6 on the bottom. So I know 8 minus 6 is 2. So I'm going to cross that off and change that to a 2. And then 7 on the top, 4 on the bottom. 7 minus 4 gives me 3. So I'm going to cross off all of them on the bottom. I'm going to be left with 3 here. And then I have 2 on the top and 1 on the bottom. So I get rid of that and be left with a 1. So I can rewrite this as 4x squared y cubed, and then z to the power of 1, or just z. Yeah, Tay, that's exactly what I've just done. Can you do 12 over 3? Which is what I've done. 12 over 3 is just 4. That's just a different way of doing it. So that's kind of the first way. The second way is you can just rewrite this whole thing. So I can go the 4 divided by or 12 divided by the 3 is the 4. So I get 4. Then I can go x to the, 8 minus 6. Y to the 7 minus 4, and z to the 2 minus 1. And then I get 4x squared y cubed z to the power of 1. So you could write it out that way, or you could just do it the way I did it. So canceling them out right in the question or subtracting them, you end up at the same spot. Just kind of personal preference, whatever kind of makes the most sense to you. So let's look at D. I'm going to deal with them separately. So if you think about what we did with C, it's kind of like 2 questions, and then we're going to multiply them at the end. So again, anything common here? Well, I see I have a 15 and a 9, and I know 3 goes into both those things. So 3 goes into 15 5 times, and 3 goes into 9 3 times. My x to the 9 on the bottom, I'm going to subtract 5. So get rid of my 5. That leaves me with 4. 8 on the top, 4 on the bottom. Get rid of all 4 of those, and I'm left with 4. I'm going to just continue on here. 3 and the 5 and the second one we can't do anything with. There's nothing common there. So I'm just going to leave that. The 7 and the 3 is going to give me a 4, and the 6 minus the 2 is going to give me a 4. So I'm just going to rewrite this now. I get 5x to the 4, y to the 4. All that is over 3. And over here I have 3 over 5, x to the 4, y to the 4. All right, so these things are being multiplied by each other. When I multiply, I add my exponents. So if I have an x in one bracket and an x in the other, when I multiply them together, I'm just going to add. You'll notice that the 3 and the 5 kind of strategically worked out in this case. And you'll see what I'm talking about here. I have a 5 on the top, so I'm going to go the 5 times the 3 is going to give me 15. And on the bottom, I'm going to go 5 times the 3 is going to give me 15. So what actually happens here is the 5 and the 3, if you like to think in terms of canceling, you're going to cancel the 5 on the top with the 5 on the bottom here. The 3 gets canceled with the 3. Or if you just divide the 15 on the top by the 15 on the bottom, you end up with 1. My x's, I'm going to add them. So I'm going to have 4 here, another 4 here. So I have x to the 8, and then y, I have 4 and 4, 8. So that's all I am left with. And again, these things always all just kind of cancel out and work out to these kind of simple answers from these really complex looking questions. So that hopefully sorts that out a little bit. There was one other question in chat, page 6, question 7a. And this one has a negative exponent. I might as well just do it. I'll give you guys some time to work on the review and then, or the learning guide here, and then about midway through this long block we're gonna have today. And then if you have any further questions, I can answer them at the end. So I have this 4 over 2, 4 to the power of negative 2, sorry. In order to make my exponent positive, I have to find the reciprocal. So what I'm going to do is I'm just going to end up putting it on the bottom. So because I have nothing on the top, I just have a 1 up there. I'm going to have 4 squared on the bottom times 5. And then 4 times 4 is 16 times 5. I don't know what that is. 16 times 5 gives me 80. So I just end up with 1 over 80 there. So the negative exponent 2 just means we put it to the bottom. Now I know maybe I didn't do a really good job of explaining the negative exponents last day. So what I'm going to do is I'm just going to talk a little bit about fractional exponents a little bit further today, because they popped up in the lesson, but I didn't really want to talk about them today, but just kind of how it all worked out. So if we can go on to lesson 3, then I'll give you guys some time to work. The good news is lesson 4 is just all the rules together. So it's just kind of a review of all of this stuff. So I can try to give you little pieces of everything, and then you'll have some time to deal with it all. So this is lesson 3, fractional exponents and radicals. The idea of this is converting back and forth between an exponent, which is a fraction, and a radical, or a radical and then an exponent as a fraction. So let's look at a couple things. 0.87 to the power of 1. Anything to the power of 1 just ends up being itself. So this is going to be 0.87. And then I have 0.87 to the power of 0. Well, anything to the power of 0 equals just 1. So if I asked you to come up with an estimate for 0.87 to the power of 1/2, what would you think that would look like? What would you end up with? Oh yeah, and that's a good point, Abby. We missed out on the last 2 questions was it just the last one? Yes, it was just the last one of the unit, lesson 2. Do I want to do that now, or do I want to do that later? Let's do it now. I apologize. We're going to take another step back. Kind of all over the place here today. Sorry for that. Let's do this last question from last day that I didn't have time to do last class. So I know I rushed through this one here, the one before it, and that I apologize for that last day, but let's spend a little bit of time doing this one because it's a similar style of question, except it's a little bit trickier. So we dealt with negative exponents. We know when we have a negative exponent, if we want to make it a positive exponent, we need to take the reciprocal, or flip, whatever that exponent's acting on. So in this case, I have the exponent of negative 3. I need to flip everything inside those brackets, and that'll make my exponent positive. So let's look at that. So whatever's here, we're just going to flip it. So I'm going to write a fraction. I had a 12 on the bottom. I'm going to put it on the top. And I had a 4 on the top. I'm going to put it on the bottom. And everything's just been flipped. Now my exponent becomes positive. All right. We also have some negative exponents within the bracket that we need to deal with as well. And the thing about these types of questions is there's like 100 ways to do them. And no way is any more correct than the other. So you can choose to deal with your negative exponents whenever you want. You can do them right at the beginning, you can do them at the end, it doesn't matter. I kind of like getting rid of my negatives at the beginning because once I've gotten rid of all my negatives, I generally don't have to worry about them anymore. So I have negatives inside of my brackets. Let's deal with those right now. So the 12 and the 4 are just going to hang out here as we could simplify them, but I'm just trying to think of one step at a time. I have this x to the power of negative 2. If I want to find the reciprocal of x to the power of negative 2, and it's on the top, I can put it on the bottom, and now my exponent becomes positive. So now x to the 2 is on the bottom. I'm going to do two steps at once here. I have this x to the negative 3 on the bottom. Because it's a negative exponent, I can bring it to the top, and now it becomes positive. So anytime I have these negative exponents, if I want them to become positive, I can just flip them to the top or flip them to the bottom. I'm going to simplify everything inside of my brackets. If I'm going according to order of operations, we can do BEDMAS. Brackets comes first. So everything in the brackets first. 12 divided by 4 is going to give me 3. I can do it as cancellation if I want. 4 goes into 3 once. I have x squared on the bottom and x cubed here. So 3 minus 2 gives me 1. So I end up with 3x, and this is all to the power of 3. So I've done what's inside of my brackets. Now I can deal with my exponents that are outside of my brackets. So if I have an exponent here, both things inside the bracket here need to get this exponent. And of course, I didn't write it in, but these both have an exponent of 1. So I'm going to go 3 times 1, 3 times 1. So I'm going to get 3 to the power of 3 and x to the power of 3. And 3 to the power of 3 is 27 times x to the power of 3. All right. So when you guys do these questions, there is lots and lots of ways to do them. You could have started at the very beginning when I first had that 3 on the outside. I could have multiplied it through by everything. It just kind of depends on how you want to approach it. Always in math, when you're doing things that have more than one method, you want to stay really consistent with what you're doing because it just makes everything easier if you do the same steps in the same order all the time. That way you kind of know how to get through these things. So hopefully that kind of doesn't confuse you. I'm going to jump back to lesson 3. And then we'll go through this stuff. I'll try to sort out this fractional exponent stuff that I introduced last day, which was foolish of me, but I did. Hopefully we can wrap our heads around it today. So we looked at 0.87 to the power of 1 was 0.87, and 0.87 to the power of 0 was just 1, because anything to the power of 0 is 1, except for that 0 to the power of 0 thing. So we had to figure out what 0.87 to the power of 1/2 was. We could probably, estimate it somewhere between 0.87 and 1. So let's fill out this little table and see where this leads us. Use a calculator to complete the second column. So I have x to the power of 1/2. If I have 1 to the power of 1/2, I have just 1. If I have 4 to the power of 1/2, that's going to give me 2. 9 to the power of 1/2. This is where we're going to break out our calculators. We got a new camera here. Let's see if I can do this. I want you guys to make sure you know how to use your calculator. So on my calculator, if I'm going 9 to the power of 1/2, I'm going to put in a 9. And then I have this y to the x button that I'm going to hit. It gives me a little hat. And then I can do it a couple different ways. I can do a bracket, 1 divided by 2, close the bracket, and hit equals, and I get 3. It's just going to depend on what your calculator looks like and how your calculator works. Another way to do this is this. I can put in 9. I can hit my y to the x button. I can go 1, and then I have a fraction button here, a over b. That means 1 over 2, and then I can hit enter. That gives me 3. So it's another way to do it. If you have an a over b button, you can do it that way. I can't think of any sort of other method that would happen on your calculator. Some calculators will accept a fraction. Sometimes you'll have to put in brackets around it. Let's see if my calculator likes this. If I go 9 y to the x 1 divided by 2. See, that doesn't work. And the reason that doesn't work is my calculator is going, okay, that's 9 to the power of 1, and then I'm going to divide all of that by 2. So the calculator doesn't understand order of operations that you're trying to feed it. So when you're putting these things in, instead of 9 to the power of 1, which is just 9, divided by 2, which is 4.5, you have to make sure to put that fraction in brackets, or as an alternative, if you have a fraction button on your calculator, you can use that as well. I have a Staples calculator here. It might be similar to what you have. Let's see if I can figure this one out. 9 to the power of, yeah, this one's going to be 1 over 2 in brackets. Gives me 3. What if I go 9 to the power of 1 divided by 2? 4.5. Again, it's going 9 to the power of 1, and then it's dividing the whole answer by 2. Do I have a fraction button on this one? I've never used this calculator before. I'm just kind of stole it from Mr. Beetlestone. I have a B over C button here. Let's try that. 9 to the power of 1 fraction 2. Hit equals 4.5. Yeah, that didn't work either. So it's giving me 4.5. That's not what I want. If I go 9 bracket 1 over 2, close the bracket. Oh, I forgot the exponent there. Sorry, 9, 1 over 2, I end up with 3. All right, so that's kind of, how does your calculator work? Back to this old song and dance again. Good question in chat. Why isn't it actually half of 9? What we're doing here is, if we wanted half of 9, we would just go 9 divided by 2, but the exponent works out a little bit differently. We're going to spend some time looking at how to convert back and forth, and hopefully that'll kind of clear up your question. So let's look at a few more examples here. 9 to the power of 1/2 was 3. 16 to the power of 1/2 is going to give me 4. And 25 to the power of 1/2 is going to be 5. So perhaps you see a bit of a pattern emerging here. It's good. Anytime we have something to the power of 1/2, we are asking ourselves what number multiplied by itself gives us that number. So in this case, it's the exact same thing as the square root. So if you can imagine that a power of 1/2 is the same as a square root, and those are all perfect squares, a little light bulb went off for Abby, which is good. What if we did perfect cubes? And instead of doing the power of 1/2, we did the power of 1/3, which is the next table. So let's fill this guy out. And again, I encourage you guys to use your calculators to try to figure out how these things work, because half the battle is your calculator. So I have 1 to the power of 1 over 3. I'll do that one for you. It's going to be 1. How about 8 to the power of 1 over 3? I wrote 2, but I meant 3. 27 to the power of 1 over 3. 64 to the power of 1 over 3, and 125 to the power of 1 over 3. You probably could figure these out just by looking at them, but it's important that you know how to use your calculator. So I need you to plug these into your calculator right now to make sure you kind of understand how it works. So I see some solutions pouring in here. 8 to the power of 1 over 3. Maybe I'll try a few of them while you guys are doing this. 8 y to the x. I'm going to use brackets. 1 divided by 3. Gives me 2. Do the next one. 27. 27 to the power 1 over 3 gives me 3. (64 to the power of 1 over 3 is going to be 4, and 125 to the power of 1 over 3 is going to be 5. Alex asked a really good question. What if it's the power of 2 over 3? And we're actually going to look at that, and I'm going to come up with a fancy little rhyme for you guys to help you remember it. So hopefully you'll remember it a little bit better. It's kind of like the foil thing. It's kind of like the feeding the chickens. This time we have another little rhyme to remember it. So we're not going to double it, but you're close, Taylor. We'll look at it here in a second. So anything to the power of a half is the same thing as taking the square root. Anything to the power of a third is the same as taking the cube root. Anything to the power of 1 over 4 would be like taking the fourth root. So if I had something squared, like 2 squared would be 2 times 2. If I have 2 to the power of 1/2, I'm going to say, okay, I don't want to square that thing, but I want to figure out what number multiplied by itself gives me that thing. Same thing with or let's go 2 to the power of 1, maybe 2 to the power of 2, or let's go 2 to the power of 3. It's 2 times 2 times 2. Gives me 8. If I have 2 to the power of 1 over 3, it's what number multiplied by itself 3 times gives me that number. So we're squaring it or taking the square root. We're cubing it or taking the cube root. We're fourth powering it or taking the fourth root of it. So let's continue on here. And Taylor, yes, it'll be a decimal, but most of the questions in this unit will work out really well, so we won't run into decimals. Sometimes the exponent can be a decimal and we'll have to convert it to a fraction, but that, generally speaking, doesn't happen too much. So in grade 9, you learn that we add our exponents if we're multiplying and the bases are the same. So I have a base of a to the m over n. We've used that a bunch of times. So we can extend this law to fractional exponents with a numerator of 1. So the example here, I have 5 to the power of 1/2 times 5 to the power of 1/2. If I go 5 to the half plus a half, 2 halves give me 1, and 5 to the power of 1 is just 5. If we had the square root of 5 times the square root of 5, we get the square root of 25. And we know 25 is a perfect square, which is just going to give us 5. So 5 to the power of 1/2 and 5 under a square root sign are the same. I guess I could put expression. They're the same thing. So we write this as a law. Anytime I have a fractional exponent like 1 over n, whatever's on the bottom is going to be the same as whatever's in front of my root sign. So raising a number to the exponent of 1/2 is equivalent to taking the square root of the number. So anytime you see an exponent of a half, it's a square root. If you see an exponent of a third, it's the cube root. They mean the same thing. So we're going to look at a few examples here, and They do get a little bit more tricky as we move on. So we're going to start with just a numerator of 1 to begin with, and then we'll move on to a numerator, something different, like Alex had a question about 2 over 3. So we'll see what that looks like. So in the orangey, yellowy box here, this is kind of the textbook definition we're dealing with. If we have something to the power of m over n, whatever's on the bottom goes in front of the radical, and whatever's on the top goes behind it. Don't worry about this if you're looking at it and you're like, oh, that's just a lot of letters. I thought we were doing math. This is confusing. We'll do it kind of a step at a time and we'll get there. So let's look at our first example as kind of our practice here. I have 27 to the power of 1 over 3. Now I know I can just plug it into my calculator, but this says evaluate without using a calculator. So we're going to say, okay, I know I can switch back and forth between a fractional exponent and a radical. So what I'm going to do is I'm just going to write it a radical. I'm going to put my 27 under it. And then I have this 1 over 3, and whatever's on the bottom is going to be what's in front of my radical. So we haven't been exposed to a lot of fractional exponents yet, but we have dealt with lots of cube roots so far. The whole last unit we did was cube roots and square roots. So I know the cube root of 27, that's a perfect cube, and that's just equal to 3. So 27 to the 1 over 3 might not make sense, but the cube root of 27 does. All right, this one kind of ratchets the difficulty up a little bit more. I have 0.25 to the power of 1/2. Now, I can write this a couple different ways. I can write it as 0.25, and instead of writing it as a fraction, I can put a 2 out front, but when I take the square root, I generally don't put the 2 there because I just know it's a 2. So I'm going to get rid of that. And you're thinking, well, I don't know what the square root of 0.25 is. You do though, because 0.25, if I took out this 0 point and I just asked you, what's the square root of 25? You would just tell me, that's easy, Mr. Borden, that's 5. All right, let's put the 0 point in there again. Now what's the square root of 0.25? Alex is on it. Gives me 0.5. Or you can think of it this way. I'll do it, I'll convert this 0.25. I know that's 1 over 4. And instead of writing it as a fractional exponent, I'll just write it as a radical. Number multiplied by itself gives me 4. Well, you know what that is. 1 over 2, which is the same thing as 0.5. So you guys know how to do this stuff. You're smarter than you think, but a lot of times when it's something new, you're like, oh no, I'd never done the square root of a decimal before. Well, I'll just pretend the decimal's not there, and it's the exact same process. 0.25, get rid of the point, it's just 25. That's just 5. So put the point back in, and you're good to go. Let's continue on here. Negative 8 to the power of 1 over 3. I can rewrite this as negative 8, and because my denominator is a 3, I'm going to put a 3 out front. Now, you may not know what negative 8 to the power of 1 over 3 is, but if I asked you to figure out the cube root of 8, you'd say, oh, that's easy, Mr. Borden, that's a perfect cube. 2 times 2 times 2 is 8. This one's negative, so it's just negative 2. Easy peasy. All right, a little bit more difficult again. Instead of a fractional exponent, I'm going to write it as a radical. I have 16 over 81, and I had 1 over 4, so whatever's on the bottom goes out in front. That's a good question, Abby. Could you also write it as negative 1 cubed root 8? Yeah. So I could write it as negative 1 times cube root of 8, which equals -1 times 2, which equals -2. If you like to do it that way, that's completely acceptable. There's nothing wrong with that. All right, fourth roots. I don't have these memorized, but I'm thinking 16 is a pretty small number, so it has to be 2 in the bottom. 81, likely going to be 3. So I could just do the math in my head. What's 2 times 2 times 2 times 2? 16. And 3 times 3 is 9, times 3 is 27, times 3 is 81. So 2 over 3. There you go. So in all these examples, I had a fractional exponent. The top of my exponent, or the numerator, was just 1. So that was kind of a basic, basic as these get. Let's look at a little bit more complex kinds of examples. The ones with the numerator not being 1. This is what Alex asked about way back at the beginning of the lesson. Jumping the gun. All right, so we have here exponents that aren't 1. They are fractional. The top is 2, the bottom is 5, right? Radical form in 2 different ways. So it's not actually even asking me to calculate it. It's just asking me to write it 2 different ways. So I know that as a general rule, a to the power of m over n, this is kind of the rule that we wrote at the beginning, or that was in that yellow box. It's going to be a to the power of m with the n root out front. So if I rewrote this, 26 to the power of 2 over 5, I'm just going to replace everything with numbers. So in this case, a is 26. So my 26 goes under the root sign. All right. The n was on the bottom and it ended up in front. What's on the bottom here? Well, I have a 5. So I can put the 5 in front. And then the 2 was on top. It ended up out back. So I'm going to put the 2 out back. So I can write it that way if I want. There's another way I could write it. Same process. I have 25. Sorry, this is 26, not 25. I'm going to write it as the 5th root. And instead of having the squared outside, I can bring it inside the bracket if I want. It doesn't matter where you put it. You can put it outside and leave brackets around this whole thing, or you can bring it inside your root. They both mean the same thing. You just need to figure out which one you like better. And in some cases, it's going to work out for you to have it outside, and in some cases, it's going to work out for you to have it inside. Here's where my fancy little rhyme comes in. I didn't think of this. I don't remember who said it to me, but I liked it. So when I have something like 26 to the power of 2 over 5, the rhyme is flour is the power, root is the root. I know flour and root, rhyming root with itself isn't the best, but the idea is this. Anytime I have something on the top, it's kind of like a flower. Here's my little flower. A little leaf. And then I have some ground. And then under the ground, I have a bunch of roots growing down into the ground. So when I say flour's the power, what I mean is whatever's on top is the power, and whatever's on the bottom is the root. Think of the division symbol as being like the ground. So we'll write flour is the power, and the root is the root. That's my rhyme. Why did we carry the top exponent on the last question? Why did we carry it? I'm not sure what you mean by carrying our top exponent. We moved it as the exponent. Maybe you can clarify while I do this next two here. Basically, we're just rewriting this. So 6 to the power of 5 under the square root sign. If we do flour is the power, root is the root. What is in front here? Well, it's just a 2, but I don't write it ever. So I know my root is 2, and my flour is 5. Flour is the power. What is the power? 5th power. So if I want to write this as a fraction, I have 6 to the power of 5 over 2. All right, like on 2, you put the 2 at the back of the 26, but didn't do it on the last page. On the last page, Taylor, we had the top was all 1s, which is different than what we're dealing with now. Now our numerators are numbers that aren't 1. They're 2s and 3s and things like that. So the reason I didn't put the 2 down before is because there was only a 1 there. So I could have, Taylor, if you wanted to think of it this way, I could have put this all to an exponent of 1, because that's what my top was. It was a 1. But anything to the power of 1 is just itself. So it's just one of these steps in math that we don't necessarily need to do, because it's just additional writing, and mathematicians are always looking for ways to do less work, because they're very lazy. All right, so the second one here is a radical, and we need to convert it into a fraction. So again, I will go to my lovely little rhyme. I'll probably say it 1,000 times before this unit's done. Flour is the power, root is the root. I have a root of 4, I have a 3 for a power. So I write down my 19. My power is my flour, and my root is a 4, so it's going to go on the bottom. We don't really even need to evaluate these things. As long as we can understand how to convert back and forth between them, we're doing okay. So the second part here down below is actually evaluating them. So converting back and forth and just simplifying if at all possible. So evaluate with rational exponents and rational bases. Remember, rational numbers are essentially, can be written as a fraction. So I have 0.01 to the power of 3 over 2. You need to resist the urge to just plug this into your calculator. These questions will, generally speaking, all just work out really nicely. So let's convert this into a question with a radical. Flour is the power, root's the root. I see the bottom is 2, so I know I'm dealing with the square root of something. I don't have to write the 2 out front, because it's generally not written that way. And my power was 3, so I'm going to have my 3. I'm going to leave it outside. You could bring it inside. I'm just going to do it after. So I'm going to do everything inside my brackets. What is the square root of 0.01? What number multiplied by itself gives me 0.01? If you know what that is, excellent. If you don't, that's okay. You can always plug it into your calculator. Take the square root of 0.01. You know it's going to be 1, because when we deal with 1s, we can't really end up with any other numbers, but it's just 0.1. I still have this cubed out back, Now if I multiply 0.1 by itself 3 times, basically all this question is doing is just moving a decimal place around. So if I go 0.1 times itself, I get 0.01. And if I go 0.1 one more time, I get 0.001. Maybe not the best example to start with because it's kind of hard to see what's going on. You're just moving the 0 and things around. What I would like you to do or suggest you do is test out your calculator. So the question we were dealing with was 0.1 to the power of, bring it back, 0.01 to the power of 3 over 2. So I'm going to plug it in here. 0.01 x to the y, 3 over 2. Just to confirm that what I've done in my calculator is going to work out. So this is where it's really important that you understand how to use your calculator and you can trust in the answer that it's giving you, because it's a good idea to check your answers to these questions once you get to the end. So if I plug that in, I throw in the enter there, and I see that I get a really strange number, 1e negative 18, which is not what I was hoping for. Let's try that again. 0.01. There we go. It's obviously entered something wrong. So I have 0.01 to the power of 3 over 2. And I get 0.001, which is exactly what I ended up with on my page. So again, calculator is half the battle sometimes. 0.01 to the power, maybe if I get rid of that, I can go to the power of 3a over b to the 2. See if that works out for us. 0.01. It just depends on how your calculator is willing to accept these numbers. So it's kind of up to you to make sure you understand your calculator. If you're having issues with it, there you go. You gotta speak up and ask for help, or see me, or send me the model number of your calculator and I can find it and figure it out for you. But until you do that, you're probably going to be a little bit confused. You're getting 0.03. What's probably happening is your calculator is not liking the order you're putting things in. So when you plug it in, you probably have to put the 3 over 2 in brackets. Even though if you don't have the secondary display screen up above like I have here, if you don't have that, that's fine. You'll still likely have a brackets button on your calculator, so you're going to want to use that even if it's not showing up in the top. So pick something really easy that you know how to do, just like 4 to the power of 1/2. It's just the square root of 4, which is 2. So when you're plugging it in, again, 4 x to the y, bracket 1 divided by 2, close the bracket. Calculators don't like it if you don't close the bracket either. So if that's something that's kind of happening to you, then make sure you're closing that bracket. Just keep trying it different ways until it works out. And then whatever you just did, do it that way all the time. I'm going to continue on here with this. In the end, you likely won't need to use your calculator very often, but sometimes it's kind of handy to just check your work. All right, so negative 27 to the power of 4 over 3, I'd think about it. I don't know what that is. 4 over 3 just doesn't make sense, but I can rewrite this as a radical, and hopefully that will clarify things a little bit. So flour is the power, 4 is my flour, it's going to be my power. And the root is 3, and I'm going to write it out front because it's a 3, not a 2. Put in the negative 27 under my radical sign. Now at this point, I know what the cube root of 27 is. That is 3. And because it's negative, I'm going to write this as negative 3. I still have this power of 4 on the outside. So I'm going to go, okay, power 4, 3 times 3 is 9 times 3 is 27 times 3 again is 81. And there we go. End up with 81. You could check it in your calculator if you want it, or you can just trust me. It's up to you. 2 more here, and then we'll go from there. So 81 to the power of 3 over 4. Again, same process. I want you guys to do this one for me. Just have a go. See if you can write it down properly. Even if you can't calculate the roots and do the powers, just see if you can switch it from that fraction to the root. Hopefully, you ended up with something like this. The power here was 3, so I'm going to write it out back. The root was 4, so I'm going to write it in front. And I end up with 81 under the root 4, and then raised to the 3rd power. Number times itself 4 times, which gives me 81. Going to be 3 cubed, and 3 cubed is 27. Avery's asking a question about the quizzes. On the quizzes, when it says write in simplest form, do we evaluate it or just write the question in simplest form? I guess it kind of depends on the question. If you have numbers with exponents, which are numbers, then you're just going to, calculate it through. Generally speaking, if you have something like that, it'll say evaluate. So you're going to find the solution. If you have a question that just says simplify, you probably have like variables in there like x's and y's. So you want to make sure that you've just simplified the exponents as far as you can go and things like that. So if it says evaluate, generally you have numbers to deal with. If it says simplify, you probably have variables in there. So you won't actually be able to get to a number. Hopefully that kind of makes sense. And you kind of need to judge by the solutions that you see there as well. I don't know if that answers your question, but use your best judgment, I guess, is what my answer is. It's different for each question. Last one, 0.75 to the 1 over 2. Or sorry, 1.2. I'm going to put in a little note here. 0.75, the 1/2, or 1 over, or 1.2. If we don't have any perfect roots, we have to use our calculator. So I don't have a perfect root here. 0.75, it's not a perfect cube, it's not a perfect square, it's not a perfect 4th root. The 1 over 2 I could rewrite as 12 over 10. That really doesn't get me very far. So what I can do is I can write this as 0.75 to the power of 12 over 10, which is the same thing as 0.75 to the power of, if I simplify that, 6 over 5. It's not going to work out nicely. I could write it like this, the 5th root of 0.75 to the 6th power, but I know that the 5th root of 0.75 isn't going to work out very nicely, and then the 6th power is not going to work out nicely. So I'm just going to end up with a decimal here. So we might as well find what it is just to work on our calculator a little bit. 0.75, I'm going to go x to the y, I'm going to use a bracket, and I said 6 over 5, so 6 divided by 5. I'm going to close my bracket, check that everything looks okay in there, and then I'm just going to go with equals and see what I end up with. So it's just this mess of decimals. So 0.0708, maybe I'll just go with that. 0.708. So that one didn't have any perfect roots. It's not going to work out nicely. Just kind of how these things go sometimes. Generally speaking, the majority of questions you'll encounter, they'll work out very nicely for you. But every once in a while, you'll see one of these curveballs, and it's this 0.75 to the power of 1.2, and it's just going to be a decimal, and there's just nothing you can do with that other than just writing it as a decimal. 12 over 10 is this 1.2, so 12 divided by 10 is 1.2, just converting the decimal to a fraction. All right, I'm thinking that's that. And I'm thinking that's some math for today that you guys have seen. So like I said at the beginning of the class, maybe if you signed in late, you didn't catch me, but Mrs. Ward will not be doing English today. So I'm just gonna continue on here. But we're gonna probably take a little break here. So if I just take a quick look at the course back in Moodle, we did this lesson last day, lesson 2. And there is an extra practice sheet that I've included here that I really think it's valuable if you guys go through it. So I'm just going to open that up. This is all of the negative exponent stuff that we did last day. So the learning guide's great. It has some examples in it, but it doesn't have enough. And I know sometimes doing more and more, if you're not getting them, or if you really understand it, isn't going to be a lot of a benefit. But the thing with this sort of section is there's so many different types of questions you're going to encounter. We can put exponents anywhere. You can end up with negatives and positives or fractions. You can have exponents inside the brackets, outside the brackets, and just kind of the next section we do kind of just, it's just everything all on you all at once. So I strongly encourage you guys to try a few of the extra practice ones I've included here, just so you can kind of get a feel for what sort of things you're going to encounter. Let's take a quick look at the learning guide. I asked you guys to do up to 12. You had some negative exponents there, but nothing crazy in terms of fractional exponents or rational exponents. So hopefully you had a chance to do that. I'm going to give you guys 20 minutes here. You can grab a drink and a snack. I know I'm pretty hungry. Taylor has some questions. I'd like you guys to do just a little bit of work and just work through these questions. So I want you to try some of question number 13 on page 7. Those are tricky. Maybe try A and C if you haven't done those yet. I mean, you're going to do all of them, but in the next 20 minutes, I'd like you to just try these. Rational exponents. Maybe try number 4, A and C, 5, A and C. So that's on page 8, 4 and 5, A and C. And then we'll just take a little break to there. So I think that's probably about 10 minutes of work. There's 6 questions there I'd like you to do. Page 7, 13, A and C. Maybe I should write this down. Page 7, number 13, A and C. And page 8, number 4, A and C, and number 5, A and C. So try those 6. I'll go through anything else you have. After the break, I'm going to answer any questions you guys had about this or anything else in the learning guide, and then I'm going to go on to the kind of application stuff. So we're going to look at all the rules all at once, but for now I just want to get you guys into the fractional radical stuff. So we're going to leave it there, 20 minutes. Have a little go at those. Grab some sugar, something good, fill your belly. glass of juice or something, bring you some brain power back, and we'll see you guys in 20 minutes. All right, guys, welcome back. Hopefully you're there. If you're not there, hopefully you're running towards your computer. If you can give me a green check just so I can make sure things are kind of going okay and you guys are all back with me, and we'll just continue on once we make sure everyone's ready to go. There we go, see some checks coming in, so everything seems to be okay. Apparently people took extended break, 30 minutes or so. All right, so I left you guys with 6 questions just to look at, see what you can do with them. I'm sure there'll be a few questions about them, and I don't mind going through them. The next, I should probably just look. I think there's 2 more lessons in this unit, and the next one is just kind of everything all put together. So we have lesson 3, which we just did today, lesson 4. So there's only one section left, applications of exponent laws. So I kind of want to spend a little bit more time on this stuff because I understand it's a lot. And I know from teaching this course a few times that of all the sections that kind of get confusing, this is kind of the point. So we've introduced all the individual laws. When we multiply, we add. When we divide, we subtract our exponents. We've looked at negative exponents, you take the reciprocal. And when we do each of the individual things, it seems pretty straightforward. But then when we throw them all together in one big question, it just kind of breaks down. There's just so many steps to these things, and they're so overwhelming to just look at. So the most important thing is you just pick something and you do it. So if you're gonna do your division, go for it. If you're gonna get rid of your negative exponents, go for it. Don't try to do everything at once, just take it a step at a time. So they get a bit involved. So I see some questions in chat. Page 713C, 2 people have asked for that, so I'll do that. And then page 5, 2B, I can get to that one as well. Anything else? Maybe just look quickly at the 6 questions here that we assigned. So first one was page 713C. All right. Let's do this one first, and then maybe I'll go over one of the next question as well down below on page 8. So the first thing we want to do is you can start wherever you want. And I think it's important that you guys figure out which way you like the best and you just stick with that. There are sort of many paths to the right answer. It's kind of like if you're driving somewhere. You guys, I guess, aren't driving yet, but I love driving. So if I'm going to, let's say, Vancouver, there's lots of ways to get to Vancouver. You can go to Vancouver going through Merritt and then down the coast, or you can go to the whole Princeton. You can go down through Princeton and over, or you can go from Merritt across and then down Highway 1, kind of like through Kamloops there. So there's lots of different ways to get to Vancouver from Kelowna, just like there's lots of different ways to do these questions. Just because you choose a different route, it might take a little bit longer, but maybe it's more scenic. There's more to see on the way, a little less traffic, whatever works for you. So what I'm going to do is I'm just going to focus on everything inside the brackets. And I had this -3 exponent here, and I want to get rid of it because I don't like negative exponents. So I'm going to flip everything inside. I'm going to make my exponent positive. So what I'm doing is just rewriting everything flipped. So I had a -2x to the -4, y to the -2. That was all on the bottom. Now it's on the top. I had a 5x to the -3, y to the -3. That was all on the top. Now it's on the bottom. So what I've done is I've just taken the reciprocal. The reciprocal of everything inside that bracket. Now, I can do a couple things. I have negative exponents inside my bracket. So I can get rid of my negative exponents, or there's nothing saying that I can't just subtract them. I can go -4 minus -3. What does that give me? I can do it that way if I want. What I'm going to do is, I don't like these negative exponents in the brackets, so I'm just going to flip everything with a negative exponent. So if it was on the bottom, I'm going to move it to the top. If it was on the top, I'm going to move it to the bottom. So the negative 2 and the 5 stay there. My power of 3 stays there. What I'm going to do is just anything that was negative, I'm going to flip it. So let's start with this x to the negative 4 here. It was on the top, it was negative. If I want to make it positive, I'm going to take the reciprocal. So x to the 4, I'm going to put it on the bottom. That is the reciprocal. I could write it out in a bunch of steps and have 1 over x to the 4 and multiply it in, and it would just end up back there again. This x to the negative 3 on the bottom is negative, so I'm going to put x to the 3 on the top as positive. I have y to the negative 3 on the bottom, y to the positive 3 on the top. Looks like I lost a y along the way here. Y to the negative 2 on the top, y to the 2 on the bottom. So if it's negative, I can move it to the top or move it to the bottom and it becomes positive. I've taken the reciprocal of everything. The next thing I'm going to do is do the subtraction. So here we go. Negative 2. I have x to the 3 on the top, and I'm going to subtract, and I'm going to end up with 1 on the bottom, and 3 on the top here, and 2 leaves me with 1 on the top. So this may be where you guys were getting a little bit caught up on this one. Normally the number I have on the top here, the 3 in this case, is bigger than the bottom, but that didn't work out this way. So I have 3 x's on the top and 4 on the bottom. So I end up having an x on the bottom, which is fine. There's nothing wrong with that. I have a y on the top, and then all of this is to the power of 3. And an attempt to keep this on the page, I'm just going to put this over here. So everything inside my brackets gets the power of 3. Negative 2 to the power of 3, y to the 3 times the 1 that was there, so that gives me 3. On the bottom I had 5, and then x, so 5 to the 3 and x to the 3 as well. Negative 2 times negative 2 times negative 2 gives me negative 8, y cubed. 5 times 5 times 5, 125, x cubed. So that is kind of as simple as it gets. Anything common between 8 and 125? Likely not. The only thing you don't want to end up with is negative exponents in your answer. So that's kind of the only thing you can't have. So your exponents must be positive. Must. There we go. I'm going to go through one of the next and then the following. I was getting big numbers for A and B. Was I doing something wrong? For this same question, Abby, I assume you're talking about the number we're on here. And then Taylor, you have a question about the 8 and 125. The 8 and 125, Taylor, comes from this 2 to the 3rd power and 5 to the 3rd power. So 2 times 2 times 2 is 8, and 5 times 5 times 5 is 125. You're going to end up with big numbers here because it's everything to the 4th power. I can just quickly go through it. Maybe I won't show as many steps. So the first thing I'm going to do is flip everything. 5b to the 6, 2a cubed, and everything's to the positive. I can't simplify anything, so 5 to the 4th power, geez, what's that going to be? I looked at the answer, they didn't solve the exponents with the number basis. Oh, okay. So if they've left the bases as just exponents, that's fine. I don't know if that's common or not. I would expect that they would actually calculate those out if they're asking us to evaluate, so that's kind of what I'm going to stick with. 5 to the power of 4 is 625. Okay. So everything inside the bracket gets the exponent 4. So 5 to the 4, 625. B to the 4 times 6 is 24. And then 2 to the 4 is going to be 32. 2 times 2 is 4 times 2 is 8 times 2 is 16. 16. A 4 times 3 is 12. So that one doesn't simplify down quite as far. Doesn't look quite as nice. Just kind of what it ends up being. So if you're there, and that's good. Page 7. (10A). Sure, while I'm here. Everything inside the bracket gets the 2. So 4 to the 2, just multiplying these things through. So 4 squared, a to the negative 4, b to the 10, c to the negative 6. Now I know I can't have negative exponents in my answers, so I'm going to evaluate the 4 squared, which gives me 16. I have b to the 10, which is positive, and then I'm going to find the reciprocal of a to the negative 4, put it on the bottom, a to the positive 4, and c was negative on the top, so I put it on the bottom and it becomes positive. So 16b, 10a4, c6. Hopefully that clarifies that one a little bit. I'm going to scroll down to number 4. Well, I guess you guys have the answers to these, but maybe I'll do them anyway. So let's do C here. I have an exponential power and it's negative. So if I want to find positive power, I'm going to have 1 over 5, 5 over 2. This was the common mistake that I warned you guys about. Students always, if they have a negative exponent, they end up flipping the exponent, which is incorrect. When you have a negative exponent, you flip whatever the exponent is acting on. So I had negative 5 over 2. If I wanted to become positive, I'm going to go 1 over 5, positive 5 over 2. I'm going to write it as a root now. Because the bottom or the root is a 2, I don't have to put a 2 out front. I could if I wanted. 1 over 5, and then this is all to the 5th power. Likely would not include the 2 there. So that's that guy. Maybe look at C down here. Flowers the power, roots the root. Write in exponential form. So I have the 5th power and then the 4th root. I think you guys probably are okay with the really simple ones, but when you get a little bit trickier and we kind of mix all the questions up together, it gets really kind of hectic. So hopefully you had a chance to go through those 6. I can do B, sure, for 5. So everything inside the bracket looks like it just has a power of 1. I don't have to write it in, but it's there. If there's nothing, it's assumed to be a 1. So I know I'm going to have 5a, the power of, my exponent was 1, and then my root was 3. So 5a to the 1 over 3. Flowers the power, root's the root, x to the 8 over 3. And same here with this, 3. I have an exponent of 1. I didn't write it in. My root is 5. Yes, Alex, I apologize. I get so excited when I get to these. I take for granted that I've done these lots of times and the exponent laws are really kind of like in my head really well. And then, yeah, you guys kind of are catching up to me. Ava's asked a question. What if you just had the square root around the 5 and not both the 1 and the 5 in your answer? Just the square root around the 5. And not the 1 and the 5? I like up here. So you're saying, well, the square root of 1 is 1 and the 5th power of 1 is 5. So you have 1 over root 5 to the 5. That's fine as well. Same thing. I believe that's what you're talking about for 4c, yeah. So you could write like that, or 1 over 5 to the 5th. That'll do as well. All the same thing. I guess I just didn't take it a step far enough, because that 1 on the top, square root of 1 is 1, 1 to the 5th power is 1. It's just, if it's got a radical over it, just don't worry about it, sort of thing. Okay, can you do B4C? Yes, okay. Now, there were some additional questions on the learning guide that I didn't go through, and they're kind of way up in chat here now, and I don't remember which ones I went over. So forgive me if you don't mind entering something that you might want me to go over again. I know you already put it into chat, but if we can get them all in the same spot. So anything from the last couple of days you want me to go through in the learning guide, we'll have a few seconds here to go through that. Or if you're all kind of good, then we can just keep moseying on here. See a few people typing, which is good. Yeah, so as the questions coming in here, I just want to remind you guys that in the course, there is some extra practice after lesson 2, so the stuff we did last day. It would be really good. I know you guys don't have a ton of free time, and the learning guide is what you're going to submit. So if you don't do the extra practice, there's no way I'll know, but it's of a tremendous benefit for you guys to the extra practice from probably lesson 2 and 3 even. So if you can find some extra time for that, awesome. But if not, it's not the end of the world. If you feel confident with these questions, that's great. Don't worry about it. But if you're kind of like not super confident in your answer, then you might want to go back and look at those. Maybe even just pick a few of the ones you're kind of struggling with, or ones that look tricky, and go through them, because they are hard questions. There's a lot of steps, a lot of places to go wrong. All right, so a few questions in. Page 5, question 2, A and B, 6A, 5, 1A. Yes. Hopefully that's good, Bell. Yes. Okay, so I'll get to these just a second. Give Belle a second. See if she can get some of that down. Page 5, 2. Okay, let's go up to page 5. I don't even remember what was on page 5. 7, 6, 5. Page 5, 2B. Page 5, 1A. Page 5, 2B, I'll start with this guy here. Both things in the brackets get the exponent of 4. So I get 5 to the 4, m to the 3 times 4. I think we said 5 to the 4 is 625. M 3 and 4 is 12. Next one, page 5, 1A, 2AB. There's 2 2s on page 5. We could write, maybe do this one. I want a positive exponent. I'm going to go 1 over 5 to the power of negative 3. But that's going to change it to positive 3. And this is exactly what I just did, where we had the 1 on the top, and then the, I don't even need that, 5 to the power of positive 3. And then same deal with this, 1 over m to the power of 6, 1 over m to the 6. B, page 5, 1A. Thinking this may be 1A on page 5. Well, that's a bit of a mess of a question, isn't it? 3 to the power of 3, a to the power of 2 times 3 is 6, y to the power of 2 times 3 is 6, 5 to the power of 3, b to the power of 3 times 2 is 6, and 3 times 4 is 12. I can evaluate the 3 cubed as 27, 5 cubed as 125. A, B, Y, Z, all different, so I can't simplify them. That's about as simple as it gets. Page 5, 2B, 1A. Negative exponents 2A and B. Did those? I think I'm good. Okay. I would love to just fly through the next lesson. I know it's kind of frustrating that we're going through 2 today, but the stuff we're going through is just kind of the same rules again. So this lesson isn't anything new. It's just putting everything together. So this is called applying the exponent laws, and it's going to be a little bit different than the stuff in the course, but let's just see if we can get this done. I know we only have like 30 minutes, but see how far we can get. So the very top of the page is just a little box for you guys to have all of the exponent laws in one spot. So see if you can remember product of powers, quotient of powers, power of power, power of product, power of quotient, what these are. So maybe I'll write down the first step and you can see if you can figure out what the answer is going to be from there. So this was the first one, a to the m times a to the n. What is that going to give us? How about a to the m divided by a to the n? What's that going to give us? A to the power of m, and then to the power of n, a and b to the power of m, and a over b to the power of m. What are all those going to look like? Do you remember what happens for each of these things? This is kind of where this section, I don't know if it necessarily gets hard, because when each of these rules is by itself, you guys are really good at them. But when we put them all together, I think students just generally get overwhelmed. But it's all stuff you know how to do, which is kind of, I don't know if it's frustrating, but it's just kind of one of those things where you guys know how to do it. So it's like, why can't you do these questions? You know how to do each of the steps, but when you put all the steps together, it gets hard. All right, a to the m times n is going to give me a to the m plus n. So if I'm multiplying same base, I add my exponents. I'm dividing same base, I subtract my exponents, m minus n. I'm raising a power to the power, I get m multiplied by n. Power of a product would be a to the m, b to the m, and power of a quotient will be a to the m, b to the m. So those are our exponent laws. I guess there's one more that we didn't have. A to the 0 is 1, as long as a is not equal to 0. Let's see how we can put these things to use. No worries, Damon. Do what you need to do. So this is a question where we've been given values for a and b. And it says, what is all this equal to if a is something and b is something? Now, one really sort of important thing that'll make your life so much easier is simplify this first. Once you've simplified it, you should really just end up with something really basic at the end. They're always, not always, the majority of the time these questions are designed to end up with just something easy and simple at the end. So what I'm going to do is simplify it, and I don't know if yours looks as messy as mine, but it's kind of, that's how it formatted, unfortunately. So what I'm gonna do is, let's get rid of my negative exponent. So I have a to the 5 on the top, and b to the 8, and then a to the 6, b to the 9, all to the power of positive 2. So that got rid of my negative exponent. I have 5 a's on the top and 6 on the bottom, so I'm going to get rid of all of those and be left with 1 here. I have 8 b's on the top and 9 on the bottom, so I'm going to get rid of all of those and be left with 1 there. So there's nothing left on the top. Do I just write it as a 0, or what is on the top? If I have canceled everything out, what's there? Abby's on it. I have a 1 on the top. A to the 1, b to the 1. This is all squared still. So I've simplified the inside, simplified my brackets. There's just a 1 on the top. Now I need to give everything inside my brackets the 2. So the 1 gets the 2, the a gets the 2, the b gets the 2. So I'm going to have 1 squared on the top, which is 1. A squared, b squared. So at this point, I've simplified. I'm going to rewrite my question. Now I'm going to substitute these a's and b's in. Now I know a is negative 3, so I'm going to put, everywhere there's an a, I'm going to put a negative 3. And everywhere there's a b, I'm going to put in a positive 2. So I'm just going to rewrite this. 1 over negative 3 squared times 2 squared. All right, I'm going to evaluate that. 3 squared is 9, 2 squared is 4, and these things are being multiplied by each other. So I end up with 9 times 4 is 1 over 36. So again, I simplified everything. I could have put these a's and b's into the first step here, and I would have had to do like a to the 5th power and then raise it to the 2nd power, and it just would have been a huge nightmare. Really big numbers and then lots of division. But if I simplify first and then put the numbers in, it's a lot more manageable. So that's kind of what this section's all about. It's about mixing all of our exponent laws together, and then sometimes we're going to have to substitute values in for our variables. So we can use the exponent laws to simplify expressions that contain rational number bases. It is convenient to write a simplified power with a positive exponent. Remember, I don't like dealing with negative exponents. You probably don't either. Let's try to keep them positive. All right, let's look at a few more examples here. They do get a fair bit trickier. Simplify numerical expressions with rational bases. Simplify by writing as a single power. Explain the reasoning. All right, we have 0.3 to the power of negative 3 times 0.3 to the power of 5. Now when we're multiplying with the same base, we add our exponents. So we end up with 0.3 to the negative 3 plus 5, 0.3 to the power of 2. Now, we can probably leave it like that, or if we wanted to, we can go 0.3 times 0.3, which gives us 0 0.09. From what I think it was Abby mentioned, that the learning guide is leaving answers like this. I guess it just depends on what type of mood you're in. Do you want to actually take the square of the next one? This is kind of where the rubber meets the road here. This is where things get a fair bit tricky. So we have lots of exponent laws all mixed into one question, but you guys know each of the laws, so it shouldn't be terribly difficult, but it can be. The first thing I want to do here is I see that I have an exponent and another exponent outside the brackets. Now, if I scroll back up to my exponent laws, this is an example of a power of a power. When I have an exponent outside of the bracket, all I do is I just multiply the exponents. Now, don't be intimidated by the question. You guys know how to do these things. Don't worry that this is a fraction and there's square brackets and round brackets and all this. You're just multiplying these together and you're multiplying these together. So I have 3 over 2. I'm going to put the negative to the top. That's just preference. Negative 4 times 2 is negative 8. And then I'm going to multiply this by negative 3 over 2. 2 times 3 is 6. All right, fair enough. Step 1 out of the way. Now, are my bases the same? Do I have negative 3 over 2 and negative 3 over 2? Yes. I'm multiplying with the same base. What do? Well, that's easy. Go to my exponent laws. Multiplying same base. I add my exponents. So let's do that. Let's add our exponents together. So I have negative 3 over 2, negative 8, plus 6. So negative 3 over 2 to the power of negative 2. This is worth writing a little star here. I've said it before, but we should probably write it down. We must get rid of negative exponents. So when we get to the end here, we think we're done, but we're not. We have a negative exponent, so we need to just simplify it one step further. If I have a negative exponent and I want to get rid of it, I'm going to flip it or take the reciprocal. Now, I always write my negative sign on the top. So you can see that I had the 3 negative on the bottom, the 3 negative on the top, and then I flipped it. I just left the negative sign on the top. That's just preference. That's just how I like to do these questions. I always stay consistent. I don't like seeing negative signs on the bottom or the denominator, so I just always leave the top as being negative. It's just kind of how I do it. Stick with what I'm used to, and that's what I'm used to. All right. Next one, we have all the same bases, so we can just do our exponent laws. I have 1.4 to the power of 3. I'm multiplying it by 1.4 to the power of 4. So I'm just going to add my exponents. 1.4 to the power of 7 over 1.4 to the power of negative 2. I guess there's kind of 2 ways I can look at this. I can get rid of my negative exponent, or I can just say, hey, I'm dividing. When I divide, I subtract my exponents. So I have, try to write this a little more horizontally. 1.4 to the power of 7 minus whatever's on the bottom. In this case, it's negative 2. Abby mentions, I got a positive instead of negative in that question because a negative multiplied by a negative equals a positive. Am I doing something wrong for B? So the one I just did. I guess I didn't actually calculate it. So everything inside the brackets gets squared. I'd get negative 2 over 3 times negative 2 over 3. So I get positive 4 over 9. So if you ended up there, that's fine. If you wanted to leave the negative out front and leave it in this form, that's, I guess, what the learning guide is giving us for answers. So yes, the answer is positive because it's squared. I guess I just didn't take it that last step. Hopefully that clarifies that a bit. Even if you just looked at what we started with, you see we have a negative here and a negative here, and we're multiplying, so we should end up with a positive for our answer. Hopefully I'm understanding what you're mentioning correctly. All right, 1.4 to the power of 7 minus negative 2 is the same thing as 7 plus 2 is power of 9. And I could calculate that, 1.4 to the power of 9, but I'm not going to. I'll just leave it like that for now. All right, letter D, same bases. What are we going to do? Well, let's maybe add the bottom. So on the top, I'm just going to leave it as 7 to the power of 2 over 3. On the bottom, I'm going to add these things together. So I get 7 to the power of 1 over 3 plus 5 over 3. This is all the power of 6. So I'm simplifying my brackets first. So I still have 7 to the 2 over 3 on the top. 1 over 3 plus 5 over 3 is 6 over 3. That's all the power of 6. Now, 6 over 3 can be simplified. It's just 2. But I can see that I have this on the top and this on the bottom, and they have the same base. And if I know I'm dividing, I'm going to end up subtracting my exponents. So if I'm subtracting my exponents, I want to have the same fraction because it's just going to make life easier. So I have 7 to the power of 2 over 3 minus 6 over 3. This is all the power of 6. 2 over 3 minus 6 over 3 is negative 4 over 3 to the power of 6. Continue this over here. All right, I have an exponent outside my brackets, exponent inside my brackets. What do? Well, I multiply these things. But Mr. Borden, it's a fraction and a whole number. How do I multiply a fraction by a whole number? Well, you've probably done that for the last at least 3 or 4 years of your math lives. Maybe not that long, maybe like 3 years. When we multiply fractions, we're going to go negative 4 over 3 times, and this is just going to be like 6 over 1. Top times top, bottom times bottom. 4 times 6 is 24, 3 and 1 gives me 3. (24) divided by 3 gives me 8, and it's negative. Now, my answer is, I'm almost there, but I have a negative exponent. I can't leave anything with a negative exponent. So instead of 7 to the negative 8, I'm going to take the reciprocal, 1 over 7 to the power of 8. And I'm just going to leave it there. So you can see how some big, ugly mess of a question. We originally started with this horrific nightmare, and it just ends up being 1 over 7 to the power of 8, which is how these questions are kind of designed to work out. Majority of the time, you're going to get nice, happy numbers for answers. The last page here has some additional questions. There's 1, 2, 3, 4, 5, 6. I'll get through as many as I can in the next 10 minutes, but I doubt I'll be able to get through all of them. See how far we can get. Simplify algebraic expressions with integer exponents. So getting back to the idea of these exponent laws, you know how to use them. If they are just basic exponent law questions, you're multiplying, you add the exponents. One step at a time is the key here. So I can only deal with similar bases. If I'm multiplying these things together, I'm going to add my exponents. So I have x to the 3 in the first bracket plus x to the 2. And then I have y to the 2 plus negative 4. Three plus 2 is going to give me 5, and 2 plus negative 4 is going to give me negative 2. Now, I think I've finished this, but I know that I can't have an answer with a negative exponent. So I need to get rid of the negative 2. How do I do that? Well, if I want to get rid of a negative exponent, I need to take the reciprocal of it. I need to move it to the bottom. So I'm going to just put it down there, x to the 5 over 2. So these things are all the exact same, just simplifying. I guess there's a couple different ways we can look at letter B here. Whatever kind of works for you. I have 10 on the top divided by 2 is going to give me 5. And then I have a to the 5 minus 2 and b to the 3 minus negative 2. So a to the 3, 5 for my b. How come anything to the power of 0 equals 1, Alex says? That gets back to the subtraction of exponents. Are you asking about just in general, or are you asking about the, like, y is 0 to the 0 not equal 1, or y is it sometimes equal 1? Remember if I had something like a to the power of 5 divided by a to the power of 5. Well, a to the 5 divided by a to the 5 is just going to give me 1, because it's the same thing over top of itself. Or I could write it like this. A to the power of 5 minus 5 is a to the 0. And I know that if I have an exponent of 0, I have to end up with 1. Because if it's a power of 0, that means I had the same thing on the top and the bottom. I could write this as 2 squared over 2 squared, which is 4 over 4, which is 1. Or I could write it as 2 to the power of 2 minus 2, which equals 2 to the 0, which also equals 1. Just how these things work out. No problem. Simplifying algebraic expressions. So I have all of my laws. Now I have some rational exponents. So I have some fractions as my exponents. Do the laws change now that I'm dealing with fractions? No. Do I love dealing with fractions? No, I don't. But that's just what I'm left with here. So let's look at a couple of these, and then I'll set you guys free. Maybe I'll do the first two. I'll throw down the answers for the last two, and then we'll call her a day. All right, so everything inside of the bracket needs to get the exponent. A basic way to think of this is if I had something like 2x to the power of 2. Well, what does that equal? That's 2 to the power of 2, x to the power of 2. That's all I'm doing, multiplying each thing here. So I have 8 to the power of 1/3, I have 3 times 1 over 3, and b is 6 times 1 over 3. I typically wouldn't actually write this step down. I would actually just do the multiplication. So I get 3 over 3, 6 over 3. What do I know about something to the power of 1 over 3? Well, that's the cube root. It's the same thing as taking the cube root of 8. So what number multiplied by itself 3 times gives me 8? Turns out that that thing is 2. Let's write it like that. So that's where the 2 is coming from. 8 of the 3 over 3 is just 8 of the 1, and b squared. So I end up with 2ab. B squared. Yes, the 3 over 3 is just a. You can write it just as a if you want, or you can show what I did there. All right, let's do this one and we'll call her quits. I just want to say a few things before we go. All right, same base, add my exponents. 3 over 2 plus 1 over 2, y to the 2 plus negative 1. 3 over 2 plus 1 over 2 is x to the 4 over 2. 2 minus 1 is just 1. 4 over 2, 2, and then y to the 1. Again, the question started really messy and ends really simply. Don't get intimidated by these things. Just, you guys know how to break it down, one step at a time. What am I going to do? Am I going to do my addition of exponents? Am I going to do my subtraction? Get rid of my negatives? One step. Decide on what you want to do it. Then the next step, until you end up with your answer. The last two here, I'll throw down the answers. If you want to try them, you can. This one is 1 over a to the 4, and this one is 2b to the 1/4 over a squared. Again, you probably have a ton of questions you can do already, so doing these extra 2 isn't going to make or break it, but it's kind of all we have time for right now. So believe it or not, for some of you this may be the scariest thing ever, because you still haven't finished Unit 1 yet, but that's it for Unit 3. I mean, you guys have a little bit of work to do, but that's it. That's all the ideas that are going to be introduced. You guys have seen everything that's going to happen in this unit. So we kind of had a double block today, so we got through twice as much. I know it's a lot of math. It's a lot to take in. So in the course, where are we? We did lesson 3 today, and there's some hints for a couple of the tricky questions in the lesson. So we'll get the video posted up there. I would strongly recommend, short of insist, because I know a lot of you have a lot of work to get done because very few of you have written the Unit 1 test, which is kind of worrying me a bit. But there's extra practice here for lesson 2. If you go into here, there's extra practice for lesson 3 as well. The applications of exponent stuff that we just did, there's some extra practice there, but I'm not sure it's entirely necessary. There's only a couple questions on the learning guide. There's 3 quizzes. You should have a go at those. And that is it for lesson Unit 3. So there is a lot of stuff for you guys to do in math. I know a lot of you have fallen behind, and I'm doing my best to keep you guys current, but unfortunately there's so much stuff to get through that if you kind of get caught up somewhere along the way, then you're not going to be on par with everyone else. So a couple good questions here. We don't have to do this test until next week. that's why I wanted you to get the Unit 1 test done on the weekend so you wouldn't have to deal with two things. I didn't expect to have a double block today, to be honest, so I was thinking that this stuff would probably all be done by, let's see, we're going to have 2 more classes and maybe like a review class sort of thing we've been having, so the stuff would have probably been done by Wednesday. I can do a bit of a review perhaps tomorrow of all the stuff we've done, and then realistically you should be able to get this test out of the way again by the weekend. Just kind of worked out that Unit 1 and 3 were both really short units, so it seems like a lot. The next unit, Unit 4, it's a long one. So that's kind of it. That's once we're done Unit 4, it's officially halfway through the course. So Abby asked, when should we have the review in by? Let's go with like Thursday or Friday. If you've done it, perfect. Submit it today. I would be so happy if you would get that in today. I'm going to leave you with this learning guide. We now officially can do all of the questions in the learning guide. So I did a couple of those. You guys seen some of those. You guys should be, pretty good at some of these things. Applications of exponents is what we went through today. There's a couple of word problems here that get tricky. Not hard, but just tricky. Just substitute the values in essentially and just use your calculator. So maybe I'll write that down here. Use calculator. Especially for number 3. And that's it. So we've done up to page, pretty much up to 8. You just have 9 and 10. So it's really only like 6 questions left for additional work. So again, that's it for Unit 3. For those of you who are behind, which is most of us, you need to get Unit 1 done, out of the way, review in, so you can get that test written. The Unit 3 test should be done hopefully by next Monday. So I'm going to say this weekend would be a good time for you guys to do this, or Friday. Yeah, I don't know when we'll see each other again. We'll see what Mrs. Ward wants to do because she gets a double block. Double block sometime this week. So that's kind of where I'm going to leave you. I'd like you guys to try those problems, try the quizzes. I'll go through anything you want next day or maybe the following day, depending on what Mrs. Ward wants. And then we'll take it from there. So Unit 1, 2 should be done. And this unit now is kind of complete. Hopefully we can get this finished off by the weekend. So we'll probably do a couple lessons from Unit 4 at the end of the week. And then that's kind of where we'll be at. So thanks, guys. I know that was a lot of math today. And have the video up as soon as we can get it. Come next day with any questions, and have a good afternoon.